Okay, so we're on to Chapter 8. It says to graph this function. Now you can put this directly in your calculator and you kind of see which one looks the same as what we have. So when I look through this, I kind of want to look and see where we're looking at. Now, we should be able to recognize a couple things. One, we should be able to recognize that because we have x minus 1 in the denominator, okay, because we have x minus 1 in the denominator, we should have a vertical asymptote at x equals 1. All right, so if I look at all these graphs, the vertical asymptote at x equals 1, this vertical asymptote is at negative 1, this vertical asymptote appears to be at 1, this one appears to be at 1, and this one appears to be at negative 1. So the only two that are at 1 are B and C. So that at least eliminates a couple problems for us. That makes it a little bit easier. Okay? Now, the other minus 1 tells us where our horizontal asymptotes are. Vertical asymptote's at x equals negative 1, or at x equals positive 1. The horizontal asymptote is at y equals negative 1. Why is that not writing? There we go. So, vertical asymptote, x equals 1. Horizontal asymptote, y equals negative 1. So this one has an asymptote at y equals negative 1. This one has an asymptote at y equals 1. So this is in fact C. Now if I didn't know that, I can still go into my calculator, plug this in, and look at the graph. And if I plug this in and look at the graph, it should be, let's see if this graph will come up, it should be the same as what I have on my screen here, if I can get my calculator to work for me. All right, so it's not cooperating right now, so we'll come back to the calculator. But that's how we do that one. All right. So for number 37, it is C. For number 38, 38 says describe any vertical asymptotes and holes for the graph. So remember, vertical asymptotes are things that we can't cross out. If we can cross it out, there's going to be a hole. So the hole here is going to be at a point where x equals 1. So we're going to have a hole where x equals 1, and we're going to have a vertical asymptote where x equals 5. So the answer there is A. Okay. Now number 39, we have to see if anything can cancel out. So if I look here and I factor the bottom factors into x plus 2, x plus 4. The numerator is x minus 1. Nothing can cancel out, so I won't have any holes. Okay, but I will have two vertical asymptotes because I have two places where I could have 0 on bottom. So it's at negative 2 and negative 4 that will have asymptotes and no holes. So that is D. Okay, so that takes care of number 37 through 39. We're getting there. Okay, 40 is another graph. Now, unfortunately, there's nothing we can factor out. So this one, we have a vertical asymptote at x equals negative 1. And our horizontal asymptote is not at 0. And the reason it's not at 0 is because these two x values are the same power. And since that's not working, we're going to try to use an 83 and see if we can get that to work. So let's try this. Let's try to see if we can get a graph to work to show you what this looks like. Now remember, the 83s are a little bit older, so they put some lines in some places that the 84 will not. But nonetheless, we'll still be able to see it. Okay? And if we look here at this graph, vertical asymptote of x equals negative 1, we have to look here. Here's an asymptote of x equals negative 1. This one's at negative 2, so this one's out. This one's at negative 1, and this one's at negative 2, so this one's out. So we actually have already narrowed it down. So it's going to be, does our graph look like this, or does our graph look like this? So it's pretty simple now. So let's take a look here. And we're going to graph the function. We're going to graph the function. Okay, clear this out. Y equals, and now I have to remember what we're graphing. 2x plus 4 over x plus 1. And remember, when you do this, they have to be in parentheses. So let's try and straighten that out a little bit. 2x plus 4 divided by x plus 1. And notice how I've put both the numerator and denominator in parentheses. And that's kind of what needs to happen. Zoom 6 to make sure I'm on my standard window. And there's my graph. And notice the dip on the left and then the dip on the top right. And that's how my function looks. If I look back at my graph and I say, okay, which one does it look like? Does it look like C or does it look like B? And if I go back to the graph here, I think it looks a lot more like B than it does like C. Okay? So that answer there is B. All right, so that's number 40. 41, we have one more graph, and there's definitely some cancellation that can go out here. So we have to factor both the top and the bottom on number 41 and see what we get. So if we factor the numerator factors into x minus 3 times x minus 1. And the denominator factors into x minus 3, x plus 3. Okay? Now I can see that they cancel there, so I'm going to have a hole where x is 3. Okay? So if I look at my graphs, and I notice that they're smart about this, there's a hole at x equals 3, there's a hole at x equals 3, there's a hole at x equals 3, there's a hole at x equals 3. So I need to see, what does this function look like? So my vertical asymptote, I know, is at x equals negative 3. Vertical asymptote at negative 3, vertical asymptote at negative 3, vertical asymptote at negative 3. So this one is more challenging. Okay? So now we have to see, what does our function look like? And if you look around this graph, every one is a little bit different except A and B. A and B are pretty similar. So we're going to have to kind of see what the difference between A and B are. Okay? Because it's probably going to be one of those two. Now the function we're going to graph, we're not going to graph the whole thing. We're going to graph x minus 1 over x plus 3. So that's what we're going to graph. So let's take a look at that one. X minus 1 over x plus 3. Okay? We're going to go ahead and graph that. We're going to see which one it looks like. Okay, so if we go back to our paper here, which one does it most resemble? It's actually not A or B, which kind of threw me for a loop. Now it's either C or D. Okay, so now we have to figure out which one it is, and it's not that hard to figure out. If we try to figure out where this hole is, okay, is it here or is it here? So is it at the point 3 and then a little over 2, or is it at the point 3 and just a little above 0? Well, if I go into my table, so if I go back to this graph and I go into my table, second table, if I go down to 3, this one's at 1/3. It's not at 2 point something, it's at 1/3, so it's a little bit above 0. So that means that my graph has to be the one where the hole is just above 0. So this one is, in fact, C. All right. Now, we've got a few more. And we're done with graphing, I believe. Okay. So, number 42, we want to factor the top, see what that factors into, and then see what we can cancel. Okay. We know t can't equal 8 because I'll have 0 on bottom. So, actually, this and this are not possible answers because they have t cannot equal negative 8. It's t cannot equal positive 8. The numerator factors into t minus 8 times t plus 4. Remember, it's two numbers that multiply together to get negative 32, but add together to get a negative 4. These 8s will cancel out. I'm left with t plus 4, and it can't equal negative 8, so my answer is B. Okay? Now I have to factor top and bottom here. This is k minus 2 times k plus 1 over k minus 5 times k plus 1. Now remember, k cannot equal negative 1 or a positive 5. That means this one's out. Okay? Cannot equal negative 1 or a positive 5. These two k plus 1s will cancel out. So this is actually what my answer is, but k is not allowed to equal -1 or a +5. So that answer is D. Yeah, this one's out because it says -5. Okay? All right. Number 44. 44, we want to multiply across the top, multiply across the bottom, and then simplify. So across the top, we've got 3g to the 5th, h to the 5th. And on bottom, we've got 100 h squared g squared. Okay? Now, I know g and h are not allowed to equal 0, and that's why it says it in all of these, because I'll have 0 in the denominator, same thing we've gone through before. The 3 over 100, that can't be reduced, so that just stays put. So it's going to be 3 over 100. The g's, I have 5 on top and I have 2 on bottom, so g is going to stay on top. 5 minus 2 is 3. H, I have 5 on top and I have 2 on bottom. 5 minus 2 is 3. So that's our answer. So 3g to the third h to the third over 100. So it looks like our answer is A. 45 requires a little bit more work. We have to do some factoring. We've got y squared times, now this is y minus 2, y minus 3, y plus 2, excuse me. And then on bottom, I'm going to factor, well, I've already got a y minus 3. I'm going to factor a y out of here, and that's times y plus 1, right? Okay. So my y minus 3's cancel out. Now that doesn't mean that y can equal 3. Y is still not allowed to equal 3. Y is also not allowed to equal 0. And y is not allowed to equal -1. So these two are out. Okay. In the numerator, I still have this y squared. In the denominator, I have this y. So this y will actually cancel out. And 2 minus 1 is 1. So this is going to turn into y to the first power. Right? So the numerator actually becomes y times y minus 2. And the denominator is still y plus 1. Well, y times y minus 2. Y times y plus 2 is y squared plus 2y over y plus 1. Our answer is B. Okay. 46. What's the quotient? So for 46, I want to divide. Divide means flip and multiply. So I'm going to leave the left term, a plus 2 over a minus 5. I'm going to multiply that by the numerator. This, two numbers multiply together to get 15, add together to get a negative, so they both have to be negative. This is a minus 5 and a minus 3. And then a plus 1 gets to stay put. Okay. Now we cross out what we can, which is here and here. So my numerator is a plus 2, a minus 3. And my denominator is a plus 1. Now here's where it gets a little weird. What is a not allowed to equal and what is a allowed to equal? Well, I know for a fact a cannot equal 5. Okay? Right? A is also not allowed to equal -1. And from the original fraction I had here, a could not equal 3. So it's weird that it can't equal all of those things, but that's true. So our answer there is A. Okay, for these, to simplify, I need a common denominator. I know that the right side factors into 5 over m minus 9, m plus 9. So that means the left side, 4 over m plus 9, just needs an m minus 9. Okay? So this will turn into, and I'm going to distribute this 4. This is 4m minus 36 plus 5 over m minus 9, m plus 9. So now I just have to simplify that. So that's 4m minus 31 over m minus 9, m plus 9. So that appears to be letter B. Three more. Hopefully I'm not boring you guys too much. 48 is going to work out very similarly. that left-hand side of 48, that factors into n minus 7 times n minus 6. The numerator I could factor, but I'm not going to. There's really not a whole lot of reason to do that. This becomes n squared minus 10n plus 24 minus 9 over n minus 7, and I'm going to multiply that by n minus 6. Okay? And now I'm going to put this all back together. So that's what I want to do. I want to get this left side together, or this figured out, and then get it all together. Okay? So we've got our n squared minus 10n plus 24, and that's all over this n plus 6, or I'm sorry, n minus 7 and minus 6. And I'm going to subtract 9n minus 54. And it's the same denominator, n minus 7, n minus 6. Okay, so we have n squared, negative 10n minus 9n is a negative 19n, positive 24 minus a negative 54. That's a positive, what's that, 78? And that's all over n minus 7 times n minus 6. Now I'm trying to think to myself, are there any two numbers I know that multiply together to get a positive 78 and add together to get a negative 19? Well, 78 is 13 times 6. So this top actually factors into n minus 13 times n minus 6. That's all over n minus 7 times n minus 6. So, unfortunately, if you stopped right there, you didn't go far enough, and that's why the answer is not up here. Okay? So I'm left with n minus 13 over n minus 7. That's A. Okay? I'm going to go ahead and clear that so I can do number 49. Number 49, okay, if I want to work this out, all I have to do is cross multiply. So I've got negative 4x, and remember I have to distribute that negative 4 to both of them, so it's minus 20 equals negative 1x minus 1. I'd add x to both sides, and I'm going to bring this over here. This would be negative 3x minus 20 equals a negative 1. I'll add 20 to both sides, and I'll get negative 3x is equal to 19. I'll divide that by negative 3. And I'll get x is equal to negative 19 over 3. So it looks like it is C. And the very last one requires a little bit more work, so I'll shift that down, give myself a little bit more space. All right, very last one, almost all done here. Remember, this left-hand side is, if I can get this working right, it's 6 over x plus 3 times x minus 3 minus 1 over x minus 3. And now I want to get a common denominator, so I'm going to multiply the top by x plus 3, top and bottom, and that equals to 1. Okay? So now the whole left-hand side is going to be over x plus 3 times x minus 3. The numerator, okay, we could probably do this in our heads, but let's write it out. It's 6 minus x, and then it's going to be minus a positive 3. And that equals 1. Or this says 3 minus x over x plus 3, x minus 3. That's equal to 1. And I'm going to put that as 1 over 1. And then I'm going to cross multiply. Okay? So here's where it gets a little bit different. The left-hand side is just 3 minus x. And the right-hand side is this x plus 3 times x minus 3. But remember, x plus 3 times x minus 3 is just x squared minus 9. So we're going to make that x squared minus 9. And the reason we're going to do that is because that's the only way we're going to be able to factor this thing. So move your x over. So I get 3 is equal to x squared plus x minus 9. Remember, I can't combine them. They don't have a squared. They don't both have a squared. Subtract 3 from both sides. We get 0 is equal to x squared plus x minus 12. So I need two numbers that multiply together to get a negative 12 and add together to get a positive 1. Well, that's x plus 4 times x minus 3. And that's equal to 0. So that means x equals negative 4 or x is equal to 3. Now, when I get two answers like that, I always need to double check and make sure that they both work. If I plug negative 4 in here to both of these, I won't get 0 in the denominator. So I know negative 4 is definitely an answer. However, if I plug 3 in right here or right here, I will get 0 in the denominator. If I get 0 in the denominator, it means 3 is not an answer. That's kind of a trick question. Number 50 is A. Good luck. Have a great weekend.